And later on, you can figure out that manager got that device ID, and if the traffic increases for that manager, you might know there's something strange going on in that company. Let's come to the point where we can say what we found in those protocols. First of all, the SRP itself, whenever you connect to those RIM environment, you can use the SRP session key, which is not seen as a secret for most of the people, and they just provide it on the web pages. You just Google for it. And if you use that key and connect to RIM and say, here, I'm the one using that session key, what happens next? His session gets dropped. He cannot log on anymore for a long time. And RIM does not know about it. And his email service is out of service for a while.
So the thing about this key is, and I think we're going to show it later, it looks like a license key. And what happens to a Windows administrator that gets a long list of character, dash character number, dash character thingy, and needs to enter that in the setup dialog? Well, it looks like a product license key. It's a sticker on the CD, like with Office or your arbitrary porn reader or whatever. So basically, they think it's a license key, and therefore, it's not perceived as a secret, while at the same time, it's actually their only way to authenticate that they are who they are against RIM, which is an interesting, interesting in terms of perception. If it would be clearer that this is a password or a very important value, people wouldn't put slides on it.
In addition to that, in the config dialogues from the enterprise server, you even see these keys in clear text, and that doesn't even help to get people into the information that is high value information and you shouldn't share it. The next thing we found with this SRP string tag, we got this 53 tagged SRP field. The length field there got a little integer problem. The one thing is, if you put a too big number in, the process just dies. So you might be able to, you might be able to, somehow crash those processes. And the other option is, if you put a value of -5 into that field, the process runs forever and loops and loops and loops and loops and loops. The interesting thing is, what we found out, that any process we've seen on site on the BES enterprise server is using the same implementation and is looping all the time. The question would be now, if that happens also on RIM side, if you send a packet to RIM. And if you send a multiple packet to RIM, maybe all of their processes go in loops. And
which we didn't try.
So, and all their processes going in loops and not coming back. So they might be out of business for quite a while and never figuring out why.
Apparently that's not the case. According to testing done at RIM's side, that's not the case, and actually even we hope that they're right.
Okay, the next thing within these SRP protocol, since we have shown that the pin messages go out in clear text, you can use those to send messages to you can use those to test if you can send a message to any other device in the world. We did that and we succeeded. Basically, what this says is that you can send out from 2, and you can get to send out the message to all BlackBerries in the world. And that's kind of interesting because, you know, these BlackBerries are used by managers, and these are interesting people to send spam to.
Talk about targeted marketing.
Okay, the last thing I can talk about is the over-the-air stuff. Actually, we can't talk about since we haven't seen it and we couldn't touch it. And it's actually not our home ground, so we haven't played with that. If anyone in the audience wants to, he's happy welcome. But it should at least contain the GME layer again, because that's ending up on the device side. And we leave that for the audience. Yeah, that's it from my side. FX is going on with the devices and the infrastructure stuff. I send you the science of power.
Muss ich jetzt meinen
Science of power.
too short. Okay, the devices. Neat little devices, everyone loves them. I actually started hating them really bad. Oh my God, this is a weapon. So they're actually fairly interesting. But it's, yeah, let's talk about the history first because that comes in later, really interesting. And when you start looking at something that's well established and been done for a while, you start to look where they come from. And so we did that, and they actually were introduced as a pager service in the days when pager services were a cool thing. I do remember having a Skyper or something, quick thingy. So that's the time they came from. They originally ran on Intel CPUs, which is really cool because we all know Intel and all the tools work on Intel, and we can do everything with Intel. And they had a real-time OS with a support for third-party binary modules. With a lot of Google magic, you actually find very, very obscure 16 or 32-bit code that's in, yeah, it looks really old, and it actually is really old, like some of the 90s. And it's supposed to be loaded on a BlackBerry. But it took a while to figure out that it's supposed to be loaded on this historic thingy and not on the stuff that we actually had, like those. Was macht er eigentlich hier? Okay, hardware today. First of all, thanks to Frank for taking the clothes off. It's an ARM7, like in almost all embedded devices that you carry around. It got partially thumb code on it, which is interesting because it doesn't look like they wanted it this way, but it's actually doing some thumb. Got a built-in DSP, separate codec chips, 64 meg flash, 32 meg RAM, 4 MB SRAM. Basically how it looks like is this. It's a pretty decent piece of hardware. That's what you can say. The interesting part, of course, is on the backside we got like tons of connectors, and well, as much as we're not crypto people, we're also not hardware people. So when I touch hardware, it usually starts smoking. So we didn't really try it out in the Datenschleuder that you got, like this publication. There's an audit version of this, and yeah, if you are bored and you got a multimeter and you're more talented with hardware than I am, just try it out and see what it talks there. The OS architecture is really interesting. On the 7290 that we played with, we actually found a CADEC AMX4 kernel. This is a commercial real-time operating system. There are many of them out there, and they've really never been really audited. So it's a green land for everyone who likes reverse engineering. So it's a CADEC kernel. Supposedly newer devices actually run other kernels, but we only checked on a 7290. It's the most widely used here in Germany. The code for handling, and this is interesting for the GSM security people, the code handling GPRS, CDMA, and all the other protocols is, of course, residing in binary space, which means in kernel space, which means if you're talking to a BTS in a GSM network that's not too friendly to your device, there's a very high likelihood that you can actually exploit something. And still, these binary modules that I talked about, they're still used. Interesting is the way they're actually made, because that tells you about how much you get from them. They're actually DLL files, like on your Windows machine. So they're PECOF DLL files, and they're just linked against the RIM operating system and not against your Windows operating system. And they actually have ARM code instead of Intel code, but other than that, it's like a DLL. And they're still there. One of the DLLs is the JVM. The JVM is actually the biggest binary module, and I think the only one intentionally loaded so far on a BlackBerry. So it is a signed binary, And the Java version, we really don't know. The Java vendor is actually RIM, so it's not a licensed VM, which means a lot of code that they reinvented and that might be broken. Unfortunately, they actually didn't implement the full J2ME classes. For example, the reflection API doesn't work. The reason for that is, or it's actually just not there. The reason for that is that all the binaries, all the Java applets that you're supposed to put on there need to be digitally signed. And of course, you could just use the reflection API and load not signed code into the device. So out of sheer cleverness, they just took it out. It's really a pity when you get a cool idea and then figure out the classes are not there. Device control is via RIM classes, and to use the RIM classes, you need to have signed code. Now, this code signing is really interesting, but in between, there is another thing. This slide order sucks. But anyway, you have IT policies. IT policies are basically something that your administrator can send down to your device and basically set permissions for you or things that you're not supposed to do, like run someone else's code or use pin messaging. So a cool thing, by the way, is like turn off pin messaging for all the devices when you roll it out. So everyone who's implementing BlackBerry on a large scale actually uses those policies and must use them because the default settings are a bit too open. So here's the code signing deal. To actually get RIM classes to work on a real device, you have to get a signature from RIM. What they sign is, they sign a hash of the JVM binary, which is SHA-1, I think. Now, to do that, you have to pay $100 once to RIM, and basically, this is a way of authenticating you, and you have to fill out a huge form saying what company you work for and stuff. Basically, but that's the only cost you have. And then, well, you send in the binary and you have your user account and you can, the hash, and you have a user account and you can get the hash signed and then everything works. The suspicion here is that the idea is actually that they have a collection of hashes from every single binary that's ever been run on a BlackBerry, just in case that one of them turns out, hoo-hoo, I'm a virus. And they then know who wrote it because he paid for the account, which of course works in a world where nobody loses or gets stolen his credit card. But, well, not in this one. Unfortunately, Lisa tried something really, really cool, and unfortunately it didn't work, was replacing the class loader. I loved the idea, and then again, it didn't work because it's loaded somewhere, it's checked somewhere else, so it's not in the Java space. The firmware images themselves also have a signature, and it's checked in a loader, and unfortunately also in a device. The loader is a Windows program, so it's really easy to convince the loader that your signature is cool. But the device actually checks that from ROM as well. There was a discussion. I wanted to show the disassembly about the loader because it's a showcase in how easy cracking can be, like a beginner level if you want to get into cracking. But that didn't pan out for various political reasons. So this is the sequence of keys you need to press in IDA once you loaded loader.exe. That's all you have to do. You basically switch two strings, search for a signature, press enter twice, cross-reference, there. You will see a conditional jump, and this has to go away. So the next idea what we had was curing this coffee addiction of the device, meaning no Java, please. The loader actually still supports a lot of interesting features, one of them being a command line switch saying no JVM. This causes a firmware load that does not contain the Java virtual machine, so you get the naked operating system. It looks surprisingly like a 90s Nokia, or just like a pager, so it's back to mama mode. And then you, of course, have no JVM to talk to. The idea is to get other binary modules besides the JVM potentially on the device, which would then allow you to use the C API from the old pagers, which is really cool because you're basically, painting around pointers in kernel space of a crypto device. So of course the crypto doesn't get you anything anymore. We haven't actually got this to work